Welcome to T1 Academy. In our last session already I have told you what is our strategy to learn this concept. Those who have not watched that video, please go and watch that video and then come to this one, so that you will come to an idea that why we are learning the concepts in this manner only. Okay. So we will learn the concepts from the basics as I have already told you. So in that the number system is one of the important one. So we will start learning from the number system only. Okay. See, right. When it comes to this number systems, actually speaking, we have 4 different types of number system, students. Okay. Number system is actually classified into 4 different types. What is those? What are those? Means binary, decimal, binary system, decimal system, octal system and hexadecimal system. Hexadecimal system. So actually speaking, this number system is divided into 4 different types of number systems. Those are binary system, decimal system, octal system and hexadecimal system. See, when it comes to this binary system, we will have only 2 digits, those are 0 and 1, and we will indicate it with a base of 2. But when it comes to decimal system, we will have 10 digits. By seeing the word deci itself, we can say that it contains 10 digits. What are those? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and it will be indicated with a base 10. And when it comes to this octal system or octal system, means we will have the digits from 0 to 7 and it is indicated with the base 8. When it comes to this hexadecimal system, we will have the digits from 0 to 9 and alphabets from A to F. So overall we will have 16 digits and it will be indicated with some base 16. With a base 16. Now what is actually happening here is, in our day-to-day life, we are going to use this decimal system. Okay. We are not going to use this binary, octal or binary means we all know computer language, we will use that binary system to communicate with any machinery or any computer, we use that binary. And octa and hexadecimal we will use in some other aspects, but we in our day-to-day life we are going to use only decimal system. So keeping this thing in our mind, in our concepts, we will learn number system means we will purely learn only about the decimal system. Decimal system. But actually, number system means it contains 4 different types of number systems, but we will only concentrate on the decimal system. And our day-to-day activity we completely say that is 100 rupees, 200 or any numbers which we use in our day-to-day life, completely we will use based on the decimal system only. Okay, that is the reason. See, units digit means what? 10 to the power of 1. Any number, 10 to the power of 0. Any number which is starting with, which is there at the units place, it will be indicated with 10 to the power of 0. Next, 10 to the power of 1. Next, 10 square, 10 cube and so on. For example, if I have some 3432 means how I will indicate it, students? Please observe here. 2 into 10 to the power of 0. Why? Because at units place. Plus next 3 into 10 to the power of 1, tens place, plus 4 into 10 square, this is hundreds place, plus 3 into 10 cube, that is in thousands place. So we will write 3, 4, 3, 2 in this manner, that 3 into 10 cube plus 4 into 10 square plus 3 into 10 to the power of 1 plus 2 into 10 to the power of 0. Anyway, this one completely will give us the answer. This is based on the decimal system. This is based on the decimal system, students. So no need to worry. We will only discuss about this decimal system. Decimal system. We are not going to bother about this binary, octa, hexadecimal systems. In this concept, we will concentrate only on the decimal system. Okay, good. Next, this decimal system is further divided once again. This decimal system we consider it as number system and we will directly take it as number system only. Okay, this number system is further classified. If you see, observe carefully, this classification of number system, actually we are classifying the decimal system, but anyway we will learn purely this decimal system under this number system. That is the reason we will see that as classification of number system. Now, when you observe a number, a complex number students, what is happened to this complex number means usually it will be indicated with a plus ib. The complex number we will indicate it with a plus ib, where a is a real number and b is an imaginary number. Okay, A is a real number for us. When it comes to B, this is an imaginary number. Imaginary number. We will not bother about this imaginary number, or we will not learn anything about that imaginary number, but we will learn only one thing here, that is I square value is equal to -1. That is the only thing which you should know here, and when it comes to the remaining things, that doesn't matter much for us. So when it comes to this real numbers, now from here onwards our actual classification starts here, students. See, these real numbers are further divided into two categories. These real numbers are divided into two categories. One is irrational numbers, right, and the other one is rational numbers. What is this irrational numbers and what are called as rational numbers? See here, students, any number which can be written in the form of P by Q. Any number which can be written in the form of P by Q, we call that as rational number. Okay, and the numbers which cannot be written as P by Q, are called irrational. And some of the examples of these irrational numbers are pi, √2, √3, or else 2.3154638. That means non-repeating and non-terminating. That means a constant will not be repeated, and as well as it will not get terminated. These type of numbers are also called as irrational numbers. So pi, students, actually most of the students think that pi value is 22/7, but that is not a correct value. This is just an approximated value. Okay, and similarly √2 and √3, in some cases we will assume them as 1.414 and 1.732. Those are just an assumptions. That means to get a value, we are taking an approximated value there, √2 and √3. Because of that reason, we will take that as 1.414 or 1.732, but that is not a correct value or exact value. Those numbers are irrational numbers. Okay, now come to this rational numbers. This is the things about irrational numbers. We will not bother much about this irrational numbers. Now when it comes to these rational numbers, we will have different types of rational numbers. Here first one is fractions. Okay, fractions or decimals, we can also call it as decimals sometimes, and when the other one is integers. What are these fractions? These fractions are further divided into, see here, students, under these fractions only we will write the repeating decimals and terminating decimals. We will see what are those repeating decimals and terminating decimals. Now see here, for your understanding, we will see the fractions separately. When it comes to the fractions, students, if you observe carefully, we will have three types of fractions. One is proper fraction. See, students, we should know all this terminology. The reason is we don't know what they are asking in the examination. So we should know what are the meanings of this proper fraction, improper fraction. We need to know the difference between these proper fractions and improper fractions. All the terminology we should know. Then only we will go to the formulas or any methods or procedures. So because of that reason, we will learn everything. Now proper fraction means if the denominator is greater than numerator, we call that as a proper fraction. That means examples for this is 1/2, 3/4, 5/6. If you observe carefully, in all these cases, denominator will be greater than the numerator. And similarly, improper fraction. What are called improper fractions means if numerator is greater than denominator. Then we call them as improper fraction. Examples for them are 3/2, 4/3, okay, next 8/7, something like this. All these numbers we called as improper fractions. See here, students, in our mathematics, we write either our answer in proper fraction, we will never write our answer in improper fraction. From this improper fractions, we will have one more thing that is called as mixed fraction. Okay, we have one more thing that is called as mixed fraction. What are called mixed fractions? 3 by 2 I can write it as 1, 1 by 2. I can write 3 by 2 as 1, 1 by 2. I hope everyone knows this, how I am writing this. 3 and 2, 2 ones is 2 and the remainder is 1. So, 1, 1 by 2. We will write it as 1, 1 by 2. And similarly, 4 by 3 we can write as 1, 1 by 3. And 7 by 8 we can write as 1, 1 by 7. 1, 1 by 7. So, these type of numbers we called as mixed fractions. So, in any mathematics examination or anything, in any other thing, usually we write our answer either in proper fraction or in mixed fraction. We never write our answer in improper fraction. Remember this one carefully, students. Definitely in mathematics, we will write our answer either in proper fraction or in mixed fraction. We never write our answer in improper fraction. If there is any answer in improper fraction, we will convert that into mixed fraction and write that as our final answer. Okay, understood? Next, okay. Next, when it comes to this decimals, repeating decimals, that means what? For example, if I have something like this, 0.33333, 0.3333, something like this. So, is this a rational number or irrational number? Actually, this is a rational number. We can write this in a P by Q form. How we can write this one? Means, see here students, 0.333, can I write this as 0.3 bar? Yes, we can write it as 0.3 bar. Okay, good, superb. Now, I will assume x is equal to 0.33333 for time being. I will multiply 10 on both sides. When I multiply 10 on both sides, it will become 10x, and when I multiply 10 to this, what it becomes? 3.33333, something like this. Am I correct? Now, what I will do this one is 10x is equal to 3 plus 0.333. I am splitting that one. Next, 10x is equal to 3 plus 0.333 means what? X. I will replace that with x. Now, when I send that x to this side, what it becomes? 9x is equal to, right, 3 I will get. 9x is equal to 3. Next, x value will become what for me here? 3 by 9. X value becomes what for me here? 3 by 9, which is equal to what? 1 by 3. So, I can write it in the form of P by Q, right? Yes, we can write it in the form of P by Q. That means repeating decimals, that means anything, 0.43. This is a terminating one, right? I can write it in P by Q form. How I can write? 43 by 100. I can write it in a P by Q form. Yes, I can write. If there is anything in a repeating manner, yes, we can write that also in P by Q forms. This is the process to write them in P by Q form. Later, don't worry, we will see some set of these questions, how to write all the repeating decimals into a P by Q form. We have some set of questions. At that time, we will see. But for time being, this type of decimals or repeating decimals are also called rational numbers, Why? Because we can write them in the form of P by Q. But while discussing that irrational numbers, I have given one example, right? Something like this, 2.431287613 like this. It will not follow any particular pattern, and it is a non-terminating one. It is not following any particular pattern, and as well as it is a non-terminating. That means it is not getting ended. So, these type of numbers are irrational numbers. Why? Because we cannot write these numbers in the form of P by Q. We cannot write these numbers in the form of P by Q. So, these numbers are called as irrational numbers. But the repeating terms or the terminating one, that means termination means which have some end, we can write them in P by Q form, and the repeating one also we can write in P by Q forms. Understood? Right? These numbers are also rational numbers. Remember this terminology. This is very, very important. Okay, this is based on fractions and rational numbers. Good. Now, see here, anyway, we are done with this one in the previous slide. Just watch that one. Now, when it comes to this integers are further classified into 3 groups. What are those, students? We all know. Negative integers, 0 and positive integers. See, students, negative integers, 0 and positive integers. Don't take 0 as a positive integer. My kind request, 0 is neither positive nor negative. 0 is neither positive nor negative. Okay, we should not consider 0 as negative integer as well as 0 as positive integer. 0 is 0, that's it. If you want to take positive integers means the first positive integer is 1. The first negative integer is -1. Like this only. There is no difference. Okay. Like this we will have the positive integers and negative integers. Okay, good, superb, sir. Now these positive integers we have one more name, or the counting numbers. Positive integers are also called as counting numbers. Usually we will start counting from 1, 2, 3, 4, right? So these positive integers are called counting numbers, and they have one more name, that is called as natural numbers. So all the positive integers are called as natural numbers. All the positive integers are called as natural numbers, remember. Now when I add 0 to these natural numbers, then it becomes what? Whole numbers. Whole numbers. 0 with positive integers together we call them as whole numbers, and only positive integers we call them as natural numbers. We call them as natural numbers. Understood? Now, these natural numbers are further classified into categories based on their factors. Remember. So based on their factors, these natural numbers are divided into 1 prime numbers and composite numbers. 1 prime numbers and composite numbers based on the factors. These natural numbers are divided based on the factors. Further divided into 3 categories: 1 prime numbers and composite numbers. One is neither prime nor composite, students. Understand this one carefully. What are called prime numbers? Any number which have exactly 2 factors is called as prime numbers, and what are those factors? Those 2 factors are 1 and itself. Okay, those 2 factors are 1 and itself. Okay, exactly 2 factors we call that as prime numbers, and those 2 factors are what? Out of those 2, one first factor is 1 and the second factor is itself. These type of numbers we call them as prime numbers. Next, what are called composite numbers? Numbers which have more than 2 factors. More than 2 factors are called composite numbers. Are called what? Composite numbers. Numbers which have more than 2 factors are called composite numbers. One will have only one factor, that is 1 itself. Only one factor, and that is 1 itself. Okay. So 1 is neither prime nor composite. Natural numbers are further classified into 3 categories based on the factors. What are those? Only one factor, that is 1. Next, prime numbers which will have exactly 2 factors. What are those 2 factors? 1 and itself. Next, composite number which will have more than 2 factors. In this manner, we are going to divide the natural numbers based on the factors. Students. Now, come to these prime numbers. There are some properties of these prime numbers. What are those prime numbers? Means, see here, the first one, we can say that 2 is the only even prime number. 2 is the only even prime number. Understood? Except 2, all the remaining numbers are odd numbers. See, even numbers and odd numbers. Any number which is divisible by 2, we call that as even number. Any number which is not divisible by 2, we call that as odd number. Simple. So 2 is the only even prime number which we have. Okay. Next, second point in this one is 2 and 5 are the only prime numbers which ends with 2 and 5 respectively. These are the only two prime numbers which ends with the same digits 2 and 5. And apart from 2 and 5, apart from 2 and 5, all the prime numbers ends with 1, 3, 7 and 9. 1, 3, 7 and 9. Apart from 2 and 5, all the remaining prime numbers will either end with 1, 3, 7 or 9. Will either end with 1, 3, 7 or 9. And when it comes to the remaining prime numbers, 2 and 5, these are the only two prime numbers which ends with 2 and 5. Next one, all prime numbers greater than 3 can be expressed as 6k plus or minus 1. That means all the prime numbers we can write it as 6k plus or minus 1. It doesn't mean that all the numbers which are written in the form of 6k plus or minus 1 are prime numbers. That is wrong perception. But we can write all the prime numbers in the form of 6k plus or minus 1. 6k plus or minus 1. See students, these things are very, very important. They may ask these things as a statement based questions. They may give these things as statements and they may ask us the questions based on this. So, please try to observe these type of things. One is neither prime nor composite. These type of things you need to observe carefully. Why? Because while doing the statements type based questions, we should be very careful while taking the values what we are taking there. Okay, we will see them, but try to understand the concept for time being. Okay, next we will see what are the factors, what are called factors, what are called multiples and prime numbers and co-primes. Just now we have seen prime numbers, about prime numbers. Now what are factors? Sir, you told that only one factor, only two factors or more than two factors. What are these factors actually means? See here, for example, 10. What are the factors of 10 means? See, 1 is a factor of 10. Why? Because 1 will divide 10 exactly. Remainder will get 0. Next, 2 is a factor for 10. 10 by 2, exactly divisible, right? Then that is a factor. Next, 5 is a factor for 10. Yes. Why? Because 10 will be exactly divisible by 5. And next, 10 is exactly divisible by 10. So that is also a factor of 10. So the factors of 10 means what? The numbers, the digits or the numbers which divides 10 exactly, then those numbers are called factors of 10. So 1 will divide 10, 2 will divide 10, 5 will divide 10 and 10 will divide 10. So 1, 2, 5 and 10 are the factors of 10. Okay. So see here students, I will tell you one limit. For a number, there will be finite number of factors. Finite number of factors. That means we can say the total number of factors for any given number. Don't say that, sir, what is the factor, what are the number of factors for infinity? Infinity, the factors will be infinity only. Why? Because to which type of numbers we can tell factors means if you are able to tell a number, then after finishing telling of that number, then I can tell the factors. So don't simply say that what are the factors for infinity. It is not possible. So to tell the factors for infinity, first of all you need to tell me the infinite number, that number. So that is not the case in general. So for any particular number, for any given number, we will have finite number of factors. Finite number of factors. And similarly, multiples. Multiples means what? Multiple. When I multiply, see for 10 multiples are what? 10 ones is 10, 10 twos is 20, 10 threes is 30. That means multiples. Like this, I will have infinite number of multiples for 10, right? So for any number, we will have infinite multiples. Infinite multiples. We will have finite number of factors and we will have infinite multiples. Infinite multiples. Okay. So factors means the numbers which are exactly dividing the given number, we call them as factors. Multiples means by going the multiples of that number. That means 10 ones, 10 twos, 10 threes, 10 fours, 10 fives like this. These are called multiples and these are called factors. Okay. So why? Because from next onwards directly we will use the same words, factors, multiples, factors, multiples. You should understand what are factors. And when it comes to prime numbers, just now I told you what are prime numbers and some of the properties of that prime numbers. The numbers which have exactly two factors are called prime numbers. There is only one even factor, even prime number, that is 2. Apart from 2, all the remaining prime numbers are what? Odd prime numbers. Except 2 and 5, all the remaining prime numbers will either end with 1, 3, 7 and 9. Only 2 and 5 are the only two prime numbers which ends with 2 and 5. And next there is only one pair of prime numbers, three prime numbers, okay. One pair of 3 prime numbers whose difference between successive numbers is 2. What are those pair? Means 3, 5 and 7. This is the only prime numbers pair, 3 prime numbers pair which have the difference as 2 between them. Okay, this is the only prime number pair, remember. Apart from this, there is no other prime number pairs. That means 3 prime numbers as a pair whose difference is 2. Okay, only one pair, that is 3, 5 and 7. Okay, next co-primes. See here students, this is very important concept for us. Okay, why? Because there are many questions based on these co-primes. We should understand what are these co-primes and how we will try to get the answer, how the questions are asked from this co-primes concept. This is very important concept here students. Okay, co-prime, sometimes they may also use the word relative prime, but there is a slight difference between those two things. We don't require that much. We will consider anyway in our concept both co-primes and relative primes as same, and we will try to solve them. Now, what are called co-primes? So, any two numbers, see, don't get confused by seeing the word prime in that one. Okay, it is not like that. Only prime numbers will become co-primes. It is not like that students. Any two numbers whose highest common factor is 1. Okay, any two numbers whose HCF is co-primes means 2 or more numbers. There is no rule that only 2 numbers should be there. There can be 3 numbers also. Any pair of numbers whose HCF is 1, they are called co-prime numbers. So, irrespective whether they are prime numbers or composite numbers. See, anyway, if the two numbers contains one prime number, those two will become obviously co-primes. See, we will see some examples. 2 prime numbers are always co-primes. Am I correct? Yes. 3 and 5, like this. 7 and 11. 2 prime numbers will be always co-primes. There is no doubt in that. Okay, next, a pair of prime number and composite number also will be always co-primes. 7 and 8, always co-primes. 11 and 14, co-primes. Why? Because here 1 are prime numbers, then obviously the two prime numbers will obviously becomes co-primes, and a pair of prime number and composite number also always becomes co-primes. Why? Because their HCF is 1 only. Their HCF is 1. Why? Because for prime numbers, what are the factors? 1 and itself. Anyway, that is okay. Next, 2 composite numbers also can become co-primes, like 8 and 9. What are the factors for 8? If you observe carefully, 1, 2, 4, 8 are the factors of 8. What are the factors of 9? 1, 3 and 9. What is the common factor between them? 1, and the highest one is also 1. So, the HCF of 8 and 9 is what? 1. Highest common factor is 1. So, 8 and 9 are also called as co-primes. 8 and 9 are also called as co-primes. Anyway, actually speaking, both are composite numbers. 8 is a composite number, 9 is a composite number. But together 8 and 9 I can say them as co-primes. Together 8 and 9 I can say them as co-primes. Understood students? Okay. Don't get confused by seeing the word prime. Anyway, by default, two prime numbers and a pair of prime number and composite number will become co-prime. But two composite numbers also can become co-primes. And remember one thing, any two successive numbers will be always co-primes. Take any two successive numbers, they will be always co-prime numbers. That means 8, 9, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17. All these numbers will become always co-primes. Means any two successive numbers will always become what for us here? Co-primes. Co-primes. All the successive numbers will become co-primes. There is no other chance. Definitely the two successive numbers becomes co-primes. So now I think everyone understood what are called factors, multiples, prime numbers and co-primes. Why? Because later while solving the problems, we will directly start solving the problem, students. So you should know this terminology. Then it becomes easy for you to understand the concepts. That is the reason we are discussing each and everything in a detailed manner. Okay, we will not learn only formulas, we will learn the concepts also. Now, the same thing, prime numbers having exactly two factors. 2 is the only prime number. The only prime number ends with 5 is 5 itself. All the other 2 also 2 only. All the other prime number ends with 1, 3, 7 and 9. Okay. All the prime numbers greater than 3 can be expressed in terms of 6k plus or minus 1 or 6k plus 5. 6k plus or minus 1 or 6k plus 5. All these things which we have already discussed, students. But now please see here how prime numbers have exactly two factors. Similarly, there are some set of numbers which will have exactly three factors. Okay, which have exactly 3 factors. What are those set of numbers? Means squares of prime numbers. Squares of prime numbers will always have exactly 3 factors for us. So what are the squares of prime numbers? Let us check randomly. 2 square is what, students? 2 square is 4. So the number of factors for 4 are what? Please observe 1, 2 and 4. 3 factors are there for 8. 4. Next, similarly 3 square is what? 9. So what are the factors for 9 which we will have? 1, 3 and 9. And let us check 5 square. 5 square is what? 25. What are the factors for this 25? 1, 5 and 25. So the same thing I have written here. Any number which is a square of a prime number, that means 4, 9, 25, these are actually squares of prime numbers, right? Will have exactly 3 factors. Those squares will have exactly 3 factors, and the factors of p square is p square comma p comma 1, where p is the prime number. So the factors are also, if you observe carefully, 1, 2, 4, 1, 3, 9, 1, 5, 25. Like this, take square of any prime number. It will have those factors are what? P square, p and 1. Okay. So numbers which have exactly 3 factors means definitely that number will be a square of prime number. Then only it will have 3 factors, else it will not have 3 factors. Okay, next one. A prime number contains the digit x at units place. How many such digits of x are possible? See here, the prime number is ending with x, digit x. So how many such digits are possible? Means see here, 2 is a prime number, it is ending with 2. There is chance for 2. 5 is a prime number which ends with 5. There is a chance for 5. Apart from 2 and 5, already we discussed, all the remaining prime numbers ends with what? 1, 3, 7 and 9. All the remaining prime numbers either ends with 1, 3, 7 or 9. So how many chances I have here? 4. 1, 3, 7 and 9. So how many chances do I have here? 4. So 4 plus 2, 6. So how many chances of x I will have here is 6 chances for unit digit x. Don't forget this 2 and 5, students. Most of the students will take only, okay, all the prime numbers will ends with 1, 3, 7 and 9. Yes, all the prime numbers ends with 1, 3, 7 and 9. That is good. But 2 and 5 are also there, right? We should consider 2 and 5. For example, if the question is like this, a prime number, a 2-digit prime number. If the question is a 2-digit prime number ends with x, then how many chances of x are there? Means then our answer becomes what? 4. Why? Because in that case we are not going to consider 2 and 5. Why? Because 2 and 5 are single digit prime numbers. Okay, but in this case they didn't ask any such question, so we should also consider 2 and 5. So my answer here becomes 6. Understood? Next, prime factorization. What is called prime factorization means, see here students, to express the given number as the product of prime numbers is called prime factorization. We will use this prime factorization very frequently, so we should know what is this prime factorization means. Okay, to express the given terms, given number as a product of prime numbers, we call that as prime factorization. For example, if I have 8, what I can write 8 as 2 cube. This is called prime factorization of 8. For example, 10. How I can write 10? 2 into 5. 2 to the power of 1 into 5 to the power of 1. Product of prime numbers. 2 and 5 are prime numbers, right? Similarly, 20. How I can write 20? 2 square into 5 to the power of 1. That is 20. 4 5s are 20, right, anyway? So, writing a given number in the form of prime numbers, we call that as prime factorization. Okay, sir, good. But if the number is very lengthy, how I am going to do the prime factorization? If the number is lengthy, how I am going to do the prime factorization? That is the case. For example, if I have 200, simple, divide it with 2 tables. 2 hundreds, 2 50s, 2 25s, next 5 5s. So 200 can be written as what for me here? 200 can be written as 2 cube into 5 square. 200 can be written as 2 cube into 5 square. So writing the given number as the product of prime numbers, we call that as prime factorization. Prime factorization. Where this prime factorization is helpful, we will see. But this process we call it as prime factorization. See students, this type of simple procedures are very important for us. Why? Because later while solving the complex problems, we will use like this many simple concepts together to get our final answer. Understood? So this is called prime factorization. Okay, good. Next, prime factorization means here to express any number as a product of prime numbers, we call it as prime factorization. Now the factors. Now see here, just now we have seen doing this prime factorization and how it is linked with the factors. How this prime factorization is linked with factors, we should know that one carefully. Now see here students, what are called factors which we have usually? What are called factors means, see here, for 10, earlier we have written factors 1, 2, 5 and 10. You can say that there are 4 factors for 10. But suddenly if I ask you, what are the total number of factors for 240? Can I write in this manner? Can I write all the factors for 240? No. Why? Because it will take a lot of time. I can write, but it will take a lot of time for me. To avoid this problem, how we can do the factors? How we can find the factors, total number of factors for 240 means, do the prime factorization of 240. So what you can write? 2 120s are 240, next 260s are 120, next 230s are 60, next 215s are 30, next 3 5s are 15. So I can write 240 as what? 2 to the power of 4 into 3 to the power of 1 into 5 to the power of 1. After writing the given number as a product of prime numbers, that means after doing the prime factorization for the given numbers, to find the total number of factors, add 1 to the powers and multiply them. Add 1 to the powers means, here the power is 4, so 4 plus 1, into, here the power is 1, so 1 plus 1, into, here the power is 1, so 1 plus 1. So what I will get here? 5 into 2 into 2. So 5 2s are 10, 10 2s are 20. So the total number of factors for 240 is 20 factors. There will be 20 factors for 240. So because of with the help of prime factorization only, we are going to find the total number of factors here. Okay, the same thing we are writing it in the form of formula. Please see here, total number of factors. If n is a number which can be written in the form of, that means what is this form? Prime factorization only, right? Okay, product of prime numbers. Then the total number of factors are add 1 to the power and multiply them. 2 power is what? P plus 1 into Q plus 1 into R plus 1 into S plus 1 and so on. Like this we are going to find the total number of factors. Next, odd factors means, see here students, except 2, all the remaining prime numbers are what? Odd numbers. Except 2, all the remaining prime numbers are what? Odd numbers. So skip 2 and do the same procedure for the remaining numbers. See, I have not considered the power of 2 here. From 3 I have taken Q plus 1 into R plus 1 into S plus 1 and so on. So like this we will get the odd factors. Okay. When it comes to even factors, we don't have a direct formula for even factors, but we know how to find the total factors and we know how to find the odd factors. So from total we will subtract the odd factors so that we will get the number of even factors. Next, when it comes to prime factors, simply add the powers. Simply add the powers so that we will get the prime factors of the any given number. Next, sum of factors. This is the sum of factors, and similarly we will have product of factors, that is usually what we will do is n by sum of factors by 2. Sum of factors by 2, that is called product of factors, but very rarely we will use this sum of factors, students, very rarely. But we will use the remaining odd, even and prime factors very commonly. Okay, understood? So like this we are going to find the factors with the help of prime factorization. After doing prime factorization only, we can do all these things. So prime factorization is very, very important for us. Okay, now some basic things we will see. Okay, what are those basic things means? See here students, if you add an even number with even number, what is the resultant output? These are very, very important for statement based. Even will be the output. When you add an odd number with odd number, always an even number. When you add an odd number with odd number, what is the output we will get? An even number. If you have any doubt, take examples, students. Even number I will take 6 and even number I will take 8. 6 plus 8, what it becomes? 14, even number. And similarly odd numbers also you can take random examples. I will take 5 and 9. 5 plus 9, what it becomes? 14. So when I add odd number with odd number, what is the resultant? I will get even number. And when I add an even number with odd number, what is the output I will get? What is the output I will get is an odd number. When I add an even number with odd number, we will get an odd number. We will get an odd number. Okay. Even number with even number, we will get an even number. Odd number with odd number, we will get an even number. Even number with odd number, we will get an odd number. And similarly, when I multiply even number from even number, what is the output we will get? An even number. Even number or 0. Sometimes there is a chance for 0. So even number or 0. Even number or 0. And similarly, when I multiply an odd number with odd number, subtract an odd number from an odd number. When I subtract an odd number from an odd number, what is the output I will get? I will get an even number. If you have any doubt, take 2 examples. Same 5 and 9. But 9 minus 5, what you will get? 4. Like that. Take the larger one minus small one. Simply observe the difference. Mod. Consider there is a mod here. Consider there is a mod here. Next, even number minus odd number. We will get an odd number. We will get an odd number. Okay, understood? Like this we will take. And similarly, products also. Products also. What we will get here? Even with even. The output will be an even number. Okay, understood? Next, odd with an odd number. The output will be an odd number. 3 5s are 15. Something like this. Take 2 odd numbers randomly. Next, even with an odd number. Even with an odd number, what we will get? An even number only. Okay. Even with an even number, we will get an even number. Next, odd with an odd number, we will get an odd number. Even with an odd number, we will get an even number. Even number. So like this, we should know these basic things, students. Why? Because while solving the problems, especially on the questions based on statements, we will come across these situations. In that cases, even though if you don't remember, it is also good, but we should know how we need to take them. Take any random example. Just one pair is enough. One pair is enough. See, even with even means I will take 2 plus 4. What is the output? 6, even number. Okay, good. Odd means I will take 1 plus 3. What is the output? 4. 4 is an even number. So that logic will apply for all the odd numbers. Next, even number with odd number, 1 with 2. 1 plus 2 is what? 3, which is an odd number. Odd number. So like this, we should take our own examples to get the answers quickly. Don't take larger numbers, take small numbers, that is enough. Okay. So like this, we will have some outputs, which is very important for us, this understanding. Next one, unique solutions and multiple solutions. What is meant by this unique solutions and these multiple solutions? See here students, for a line equation, something like this, x plus y is equal to some 5. Okay. Usually we call this as a line equation. We call that as a line equation, and we will have multiple solutions for this. That means I can take infinite solutions for this. How, sir? How I can take? 0, 5 I can take. Yes, without any conditions I am speaking. Next I can take 1, 4. Next 2, 3, 3, 2, 4, 1, 5, 0. If I want, I can take negative values also, something like this, 6, minus 1. I can take, right? This, there is a chance. So what is happening? Why we call it will have infinite solutions means, if I take it in x-axis and y-axis, what will happen for me here? 1, 2, 3, 4, 5, 6, randomly we will take 1, 2, 3, 4, 5, similarly minus 1, minus 2, minus 3, minus 4, something like this is there for me. So x is 0 and y is 5. So where I will get point here? X is 1, y is 4. I will get point here. Next x is 2, y is 3. Next 3, 2. Next 4, 1. 5, 0. 6 minus 1. So when I join all these points, what I will get? A line equation. So I can have a line contains infinite points, right? So that means I will have infinite solutions for this. So whenever there is an equation which is of the form x plus y is equal to a, infinite solutions means what? Means nothing but the values which satisfies for x and y. There are infinite values between infinite rational values. I am using the word rational. Why? Because rational means I can also take decimal points. If I use natural numbers also, I will have infinite, 1, 2 like this also. So we will have infinite integers and infinite natural numbers, whatever it may be. For x and y, we will have infinite solutions. Why? Because I can take any values for x and y. So usually this x plus y is equal to a, we call it as a line equation. Line equation means this is the way it will become, and we can have infinite points on this, right? So it will have infinite solution. Whenever there is any equation like this, we will have infinite solutions without having any condition. Remember this one. Now what is when we will have this unique solution means with any some conditions. If they have given us some conditions, or if they give us two equations, something like this, x plus y is equal to 3, x minus y is equal to 5. Now to get the answer for this one, whenever you have two equations, definitely we will have a unique solution. Unique means there will be only one set of x and y value which satisfies this one. Please observe here, when I add these two equations, these two will get cancelled, 2x will become what for me here? 8. X value is 4 here. So what about y? Y value becomes minus 1. That means x is equal to 4 and y is equal to minus 1. This is the only value which satisfies these two equations. So this type of solution we call it as unique solution. We call this as unique solution. Unique solution. That means if the given statement with some, see, sometimes with this line equation also, if they give you some conditions or some set of rules, definitely we may also have unique solutions for this one also. But in general, to tell you what is this multiple solutions and unique solutions, I have taken a simple line equation. So we will have infinite solutions for this one or multiple solutions depending on the case. But in this case, we will have a unique solution. That means only one solution for x and y. We will have only one solution for x and y. X and y. That is the case of unique solutions and multiple solutions. Understood, students? So we should know what is this unique solutions and multiple solutions. Then only we can solve the questions very easily and effectively. Understood? Right. Next, divisibility rules. Now, these divisibility rules are also very, very important, students. Why? Because there are many questions framed from this concept, divisibility rules, and we don't require all the divisibility rules. Yes, we should know all the divisibility rules, but only few are very, very important for us. Now, what is the rule for 2? Rule for 2. What is the rule for 2? Rule for 2 is very simple. Divisibility rule of 2. All the even numbers are divisible by 2. All the even numbers are divisible by 2. And if except in the remaining numbers will not mean. Remaining numbers means what? Odd numbers. Odd numbers are not divisible by 2. Next, rule for 3. This is very, very important, students. While solving the problems, we will come across this rule for many times. So, if the sum of the digits of given number is divisible by 3, then it is divisible by 3. That means any number, sum of the digits is divisible by 3, then that number is divisible by 3. Very simple, right? So, now what I can say here, if you observe carefully, for example, if the example is 369, what I need to do here? First of all, I need to find the digit sum of this number. 3 plus 6 plus 9. When I add all these things, it becomes what? 18. Is 18 divisible by 3? Yes, 18 is divisible by 3. Then this entire number is also divisible by 3. That is 369 is also divisible by 3. For example, if I have one more number, something like this, 156. Whether it is divisible by 3 or not means what I will do? 1 plus 5 plus 6. What it becomes? 12. So, 12 is divisible by 3, then the entire 156 is also divisible by 3. Entire 156 is divisible by 3. So, in this manner, we will check whether the given number is divisible by 3 or not. Okay, next. Rule for 4. This one is also important for us, students. We will come across this one. We will use this for the multiple times. So, what is rule for 4? If the last two digits is divisible by 4 or last two digits are zeros, then the number is divisible by 4. Then the number is divisible by 4. That means what I will do is, I will see an example. We will take an example, students, here. Now, for example, 464. If I want to check whether this number is divisible by 4 means, I will not bother about the complete number. I will only look the last two digits. Is 64 divisible by 4? Yes, 64 is divisible by 4. Then 464 is divisible by 4. Then 464 is divisible by 4. Similarly, 5200. I will check the last two digits. Last two digits are what here? Zeros. Then obviously this 5200 is also divisible by 4. Is also divisible by 4. That means if the last two digits are divisible by 4 or the last two digits are zeros, then I can say that that number is divisible by 4. Else it is not divisible by 4. Next, rule for 5. Rule for 5 is very simple. Units digit or the last digit is 0 or 5. 0 or 5, then that number is divisible by 5. Then that number is divisible by 5. Okay. Next, we will see the rule for 6. Rule for 6. What is the rule for 6? If the given number is divisible by both 2 and 3, then that number is divisible by 6. Okay, if the given number is divisible by both 2 and 3, then the number is divisible by 6, else it is not divisible by 6. That means definitely it should be divisible by both 2 as well as 3. If it is only divisible by 2 and not divisible by 3 means no, it is not divisible by 6. Okay, rule for 7, that is not that much important. Instead of that learning the rule, simply try to divide the given number with 7. That's it. My suggestion is that is my suggestion. Next, rule for 8. Rule for 8 is similar to rule for 4. Here the last 3 digits. We will observe the last 3 digits. If the last 3 digits are divisible by 8, then that number is divisible by 8, or last 3 digits are zeros. also, then that number is divisible by 8. Okay, similar to 4. In 4 we will take the last 2 digits, in 8 we will take the last 3 digits. Okay, next rule for 9. Rule for 9 is also very, very important for us. Okay, we will use this one also very frequently. Rule for 9 is very simple, similar to 3. If the sum of the digits, is divisible by 9, then that number is divisible by 9, else it is not divisible by 9, that's it. Okay, that is the rule for 9. Next, rule for 10, it is very simple, no need to learn. Units digit is 0, then that number is divisible by 10. Next, rule for 11. What we will do is, this one is also very, very important, students. Rule for 11 is, okay, we will divide the given numbers into 2 portions. Okay, if the difference between sum of digits at odd positions and even positions in bracket taking from right side, right, is 0 or 11, then that number is divisible by 11. For example, see here, I need to check is whether 1, 3, 4, 2 is divisible by 11 or not. 1, 3, 4, 2 is divisible by 11 or not. What I will do is, I will take the odd position sum and even position sum. That means, see here, 1, 2, 3 and 4 positions taking from the right side. Okay, what are the odd positions? These 2 are odd positions and these 2 are even positions. So, odd position sum is 2 plus 3 and even position sum is 4 plus 1. So, the difference between them is what? 5 minus 5, 0. Then I can say that this 1, 3, 4, 2 is divisible by 11. Then this I can say that this is divisible by 11, and in some rarest of the rare cases, we may also get the sum as 11 or multiple of 11, difference as 11 or multiple of 11. In that case also, you can take that number is divisible by 11. Okay. Next, 12. See here, rule for 12. Okay. So, similar to 6 only, but little bit change. All the numbers which are divisible by 4 and 3 both, then that number is divisible by 12, else that number is not divisible by 8. See, actually this 2, 3, 4, 3, all these are what? Co-primes. Okay. For example, if I want to tell the divisibility rule for 15, so 15 I can write it as 1 into 15 and 5 into 3. So, all the numbers which are divisible by both 5 and 3, that number is divisible by 15. Similarly, 18. 18 I can write it as 1 into 18. I can write this one as 6 into 3. I can write this as 9 into 2. Then which one I need to pick, sir? You need to pick 9 and 2. Why? Because 9 and 2 are co-primes. 9 and 2 are co-primes. Pick the co-primes. Don't take 6 and 3. Don't consider that all the numbers which are divisible by 6 and 3 are divisible by 18. It is not like that. You should definitely pick the co-prime pair. So, you need to pick 9 and 2. That means, you need to tell that all the numbers which are divisible by both 9 and 2, those numbers are divisible by 18, else it is not divisible by 18, something like that. So, like this we need to know the divisibility rules, students. Okay, definitely we should know some divisibility rules, then only we can get the answers, else we will not get the answers. So, these are the divisibility rules. Now, we will see some examples based on these divisibility rules and some of the concepts which we have solved till now. Okay, right. So, these are basics and very, very important, students. Now, see here, 2 statements are given for us. Okay, n is a prime number. Okay, good, superb. Now, question is what? If n is a unique natural number between 10 and 20, then what is the value of n? Now, see here, by using statement 1 only, can I answer this question? See what they are telling, if n is a unique natural number between 10 and 20. Unique means definitely I need to tell a single value. Okay, we will see. And they are telling from statement 1, now this is the question and come to the statement 1. N is a prime number. N is a prime number. Now, between 10 and 20, how many prime numbers do I have? Actually, 11, 13, 17 and 19. How many chances I have here for me? 4 chances. Can I tell a unique number? That means a single number for n by using my first statement? No. Why? Because according to first statement, I have 4 chances. What are those numbers? 1, 13, 17 and 19. So, by using statement 1 alone, I cannot tell my answer. Now, I will come to statement 2, leaving that statement 1 aside. N leaves a remainder 1 when divided by 4. Okay, from this, what are the pairs of values I can take? 13 and 17. Why? Because these are the only 2 numbers which will leave a remainder 1 when it is divided by 4. See here students, now I am not even bothering about statement 1, I am only checking statement 2. 13 and 17. 2 chances are there with the statement 2 also. Can I tell a unique value? No. Here also I have 2 chances. Now, I will try to combine these 2 statements, statement 1 and statement 2. With the help of both statements, can I tell my answer or not? Now, see here, according to first one, I have 11, 13 and 17 and 19. According to second one, I have 13 and 17. By joining these 2, can I tell a single value? No. Even though by joining these 2 numbers also, I mean these 2 statements also, I have 2 chances. What are those? 13 and 17. Anyway, 2 will be eliminated. 11 and 19 are eliminated. Okay, fine. But still I have how many? 2 chances. By using both the statements also, I was not able to tell my answer here exactly. That means a unique answer means I need to tell a single answer. It is not possible. So, because of that, S1 and S2 together are not sufficient to answer the given question. Why? Because I cannot tell a unique answer here. Okay? Next. Consider 2 statements S1 and S2 followed by a question. Okay. Which one of the following is correct? We will see. P and Q are both prime numbers. Okay. P plus Q is an odd integer. Okay. And a question is for me, PQ is an odd integer. PQ is an odd integer. There is no rule that you should tell definitely it should become an odd integer, or you should tell, can you tell your answer as yes or no? You need to tell 100% yes or 100% no. Is it possible with statement 1? See, P and Q are both prime numbers. P and Q are both prime numbers. See, what are the set I need to take for P? Now tell me. 2, 3, 5, 7, 11, 13 and so on. So, by using those numbers, can I say exactly that PQ is an odd integer or PQ is an even integer? If I take 2, 3, what is the value of PQ? It becomes 6, which is an even number. If I take 5, 7, what is the value of PQ? It becomes 35, an odd integer. But I cannot tell exactly that definitely it will be always an odd value or definitely an even value, right? Why? Because of only these 2. If I don't have these 2, then I can say that yes, PQ will be always odd number only. But I have 2, right? I cannot eliminate 2 from the prime numbers. So, I cannot say exactly PQ is always even integer or odd integer exactly. So, with only statement 1, I cannot tell my answer. Now, come to statement 2. P plus Q is an odd integer. Only statement 2 I have. P plus Q is an odd integer. When I will get PQ as an odd integer, students, tell me. When I will get PQ as an odd integer. Odd integer. So, by taking what values I can get odd integer? Tell me. If I take 0 and 1, I will get an odd integer. 0 with an odd in 1, we will get an odd integer. Odd with odd, definitely an odd integer. But even with odd also, I will get an odd integer. Okay, even with odd also, I will get an odd integer. Now, see here, 0 into 1, what it becomes? 0. Is 0 an odd integer? No. I cannot tell. Even with odd integer, what you will get? 2 3s are 6. 2 3s are 6. With this also, I am not getting an odd integer. If you observe carefully, students, 0 is not an odd integer and 6 is also not an odd integer. But PQ, when I multiply these 2, definitely I can say that if by using this condition, definitely I can say that PQ is not an odd integer, right? PQ is not an odd integer. I can say exactly not an odd integer. Using this statement 2. Using this statement 2, I can say that PQ is not an odd integer. Why? Because when I will get an odd integer, tell me. Earlier also we discussed, when we will get an odd integer, when we add an even number with odd number, then only we will get an odd integer. Or else the other choice is 0 with an odd integer also we will get an odd integer. Okay, an odd integer. Why? Because 0 is also an integer, but it is not an odd integer. Remember this one carefully. Now, even into odd, what we will get? Always an even number. So, not an odd integer. 0 with odd number, what is the resultant we will get? Mean product we will get 0. 0 is also not an odd integer, but that means when I multiply even with odd, output is even. Okay, when I multiply 0 with odd, what is the output for me? 0. This one is also not an odd integer. That means PQ is not an odd integer. I can tell my answer, right? I can always say that PQ is not an odd integer by using the second statement. So, statement 2 alone is sufficient to answer the given question. Okay, statement 2 alone is sufficient. Why? Because if I take statement 1, there is 2, we may get positive or odd numbers or even numbers depending on the value 2. If we consider one of the numbers as 2, you will get odd even number. If you don't consider one of the numbers as 2, then you will get even odd number. So, there is chance for both even and odd. But in this case, I will have always an even number only. So, that means PQ is, I can say that PQ is not an odd integer with the help of my statement 2. So, here statement 2 alone is sufficient to answer the given question. Next one. Two statements are given below, followed by the conclusions. First one, all numbers are divisible by 2, all numbers are divisible by 3. See, all numbers are divisible by 2 and all numbers are divisible by 3 means what are these numbers? Yes, these numbers are nothing but all numbers are divisible by 6. Indirectly, all numbers are divisible by 6. So, what are the multiples of 6? 6, 12, 18, 24, 30. Now, these are our number sets. According to given statement, our numbers are these numbers. Now, come to all numbers are divisible by 6. Yes, all these numbers are divisible by 6. Yes, all these numbers are divisible by 6. All numbers are divisible by 4. Are all these numbers divisible by 4? No. Why? Because 6 is not divisible by 4, 18 is not divisible by 4, 30 is not divisible by 4. So, here which of the following conclusion follows logically means only one follows logically. Okay, understood? By combining these statements, first of all I have written the number set, our required number set, and on this I applied the conclusions. Okay, next one. How many integers are there between 1 and 100 which have 4 as a digit but not divisible by 4? Which have 4 as a digit but not divisible by 4. First of all, write down all the numbers which have 4 as a digits. Even though it takes some time, students, better to write the numbers. Why? Because without any confusion, you will get the perfect answer. So, what you will get? 14, 24, 34, and this set will be there 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Why? Because all this will have 4 as a digit. Next, 54, 64, 74, 84 and 94. Now, which have 4 as a digit means this many, but are not divisible by 4 and it should not be divisible. So, I will cancel the numbers which are divisible by 4. So, I will cancel 24, 40, 44, 48, 64 and 84. Why? Because these numbers are divisible by 4. Now, I will count the remaining 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, how many are there for me? 12. Even though it takes some time, better to write the on paper for this type of question, students. Okay. Next one. Right. The number 3798125 P369 is divisible by 7. What is the value of? See here, students. Most of the students will have one doubt, right? Sir, you didn't tell us the divisibility rule of 7. It is waste of learning the divisibility rule of 7. Why? Because very rarely we are going to use. To solve this type of problems, what we will do is 3798125 P369, right? So, I will divide it with 7. I will try to cancel the things. 7 5s are 35, I will be left with 2. 2 9 means what? 7 4s are 29, I will be left with 1. 1 8 means 7 2s are 14, I will be left with 4. 4 1 means 7 5s are 35, I will be left with 6. Understood? 7 8s are 56, I will be left with 9s are, and I will be left with what? 2. So, finally, my number becomes what? 2P369 divided by 7. Now, from here onwards, what you will do is simply do the option substitutions. Okay, if I take 1 for time being, so it will become 7 1s are 21, it will be cancelled, and 369 is there for me. So 369 is not divisible by 7. Why? Because if you take 0 times also, I will be left with 36, and 5 times is 35, 19, it is not divisible. So p value, taking it as 1, it is not possible. I will take p value as 6. Then what happens when I take p value as 6? For me, when I take 26 means what? 3s are 21, 53 means 7s are 49. I will be left with what? 46, 6s are 42, 49 means 7s are. So that means in place of p, what I need to take here? 6. That's it. Better to do in this manner. Don't think too much to learn the divisibility rule of 7, 13, these type of numbers. It is waste of time, students, actually. Instead of that, go with your basics, you will get the perfect answer. Next one. A digit n greater than 3 is divisible by 3 but not divisible by 6. Which of the following is divisible by 4? That is the question. A digit n greater than 3 is divisible by 3 but not divisible by 6. Now tell me, number divisible by 3 and not divisible by 6 means, what is the given set for us? Tell me what are the given set. First of all, what I need to take? Only the odd multiples of 3, right? It means that only the odd multiples of 3, and that too greater than 3. So what are the odd multiples? First odd multiple is 9, greater than 3. 3 is also a multiple. 3, 9, all these are odd multiples, but 3, 9, 15, 21, 27, 33, like this, these are the numbers greater than 3, divisible by 3 and not divisible by 6. Odd multiples of 3 will become our pair here. From this one, our pair will become what? 9, 15, 21, 27, 33 and so on. All odd multiples of 3 except 3. Why? Because n should be greater than 3. Now, which one of the following is divisible by 4? Then they are asking us, which of the following is divisible by 4? 2n. That means 2n means what? 2 into 9, it becomes what? 18. Is 18 divisible by 4? Is 18 divisible by 4? No. So this is not possible. Next, 3n means 3 into 9 is what? 27. Is 27 divisible by 4? No. By first option, first number itself, 2 options are eliminated. Now see the next one, 2n. That means what? 2 into 9 is 18 plus 2. That is what? 20. Is 20 divisible by 4? Yes. Now I will check the second one. This one. 2 into 15 plus 2. What it becomes? 32. Is 32 divisible by 4? Yes. Now I will next check this one. 2 into 21 plus 2. What it is? 44. Is 44 divisible by 4? Yes. Like this, check 4 to 5. Yes, this will be our answer. Next, check for this one. For time being, we will check this one. 3n means what? 27 plus 1. What it is? 28. Yes, it is satisfied for this. Next, I will check the next one. 3n means what? 3 15s are 45 plus 1. What it becomes? 46. Is 46 divisible by 4? No. So this is gone. That is the reason. Try to check at least for 3 to 4. It may be satisfied for one value. See here, actually 3n plus 1 for 9 it is satisfied. But is it satisfying for 15? No. So whenever, if you want to cross check anything like this, definitely try to check for 3 to 4 values. Then only come to conclusion. By checking only one value, don't come to a final conclusion. Okay. Let xyz be a 3-digit number. Okay. Xyz is not multiple of 3. Okay. They are telling that xyz is a 3-digit number. Now xyz plus yzx plus zxy. Now what we need to do here is, already I have told in my first video, go and watch in that video. You can take them as xyz, yzx and zxy while writing. But when you are performing any mathematical operation, definitely you need to expand them and then only do the mathematical operation. So xyz means what I can write here? It is in hundreds place, so 100 into x plus y is in tens place, so I can write this as 10 into y. And z is in units place, I will write it as 1 into z. Next, yzx 100 into y plus 10 into z plus 1 into x. Next, zxy 100 into z plus 10 into x plus 1 into y. Okay, I need to add all these 3. So when I add all these 3, what it becomes? 100x, 10x and 1x. It will become 111x plus similarly 100y, 10y and 1y. This will become 111y plus 100z, 10z and 1z. This becomes what? 111z. So when I take common, 111 times of x plus y plus z will become the sum of xyz, yzx and zxy. Okay. Now is not divisible by, please see here, not divisible by. So 111 I can write that as actually 37 into 3 into x plus y plus z. Yes, now see here, these they are asking us not, it is divisible by 3, right? Why? Because if I write 3 here, 3 will get cancelled. So this is not my answer. For timing, put this 9 aside. Now is it divisible by 37? Yes, it is divisible by 37. So this is not our answer. Why? Because we want not divisible. X plus y plus z, yes, it is divisible by x plus y plus z. So this is also not our answer. So our answer here becomes what? 9. Our answer here becomes 9. You may have one doubt, sir, already 3 is there. If this sum is a multiple of 3 means no. See, already x plus y plus z is not multiple of 3 means obviously x plus y plus z will not be a multiple of 9 also. Understood? Not a multiple of 3 means how it can become a multiple of 9? Not at all possible. Why? Because 3 is a factor of 9. So if the x plus y plus z is not a multiple of 3 means obviously it is not a multiple of 9 also. Okay? From that we can say our answer is here 9, or else we can say directly 3 numbers are divisible by given numbers. So 1 is not divisible, that is 9. Like this students, we are going to learn the concepts. Okay, so we will learn each and every basic concept and we will learn all the different types of problems. Understood? But we will learn them in an orderly manner. So with this session is finished. In our next session, we will see some other concepts from the number system only, and we will try to solve the problems from those concepts, right? Thank you very much.